Welcome guys. So this is our last topic for our online class. So in this video we're going to discuss about turning forces. What is a moment of forces? So turning forces is also known as moment of forces. It's the product of forces and the perpendicular distance between the axis of rotation, or other name for this is the pivot point. So the axis of rotation, also known as the pivot point. So the formula is moment equals to force times the perpendicular distance between the line of action from the axis of rotation, or in symbols it's just m equals to force times distance. So looking at this picture, so this is the axis of rotation or the pivot point, and you will have the moment, the turning point or the turning forces. Okay, and you have here the force going perpendicular to the pivot point, and in this we have a perpendicular distance. So that's how you will get the moment. And then we need to know, or we need to understand, Newton's third law, and it states that if a body A exerts a force on body B will exert an equal and opposite force on body A. So the other statement for this is for every action there will always be an equal and opposite reaction. So for every action there will always an equal and opposite reaction. So action, reaction. So if it is in equilibrium, so it just stays there. So if you release the balloon, there will be an action and the reaction. So also, if you hammer a nail down a wood or a cement, so your action is hammering it forward, and then the reaction will be from the nails. So it's like you're standing in the ground, so you have weight, and then for you not to plummet underneath the surface of the earth, there would be a normal force. Okay? So principle of moment states that if a system is in equilibrium, the sum of clockwise moments must equal to the sum of anti-clockwise moments. So the formula is like this. So the summation, so the symbol is called summation. So summation of moment clockwise equals to summation of moment anti-clockwise. So example, so suppose we have a boy and a girl in a seesaw which has a distance given. Figure shows two children on the seesaw. The weight of the seesaw is 500 newtons. So you need to consider the weight of the seesaw. It's actually been given. So if it's given, then you need to consider it. And child A has a weight of 400 newtons. So this child has a weight of 400 newton, and also the seesaw. So your question is, draw a free body diagram of the system. So the second one is, what is the moment of 400 newton pull of the earth on the beam? And finally, calculate the weight of the child B, or the boy. So first, draw the free body diagram of the system. So as you can see, the weight of the beam is this one. So if you consider the weight of the beam, you need to find the center of gravity of the beam. So if it's not even here, so if the system is not even, you need to like find the center of them. So all the forces going up is equal to the weight of the children and the weight of the beam. Then what is the moment of the 400 Newton pull of the earth on the beam? The weight of the beam acts through the axis of rotation, and so the moment is zero. So there is no moment because it is on the rotation or the axis of rotation, which is being held by the uh, the beam on the middle. So this one, as you can see. So calculate the weight of child B. So using the principle of moment, the formula that we have, so the axis of rotation is at the center of the beam. So this is our axis of rotation. Then clockwise moment, which is equals to moment clockwise equals to the weight P, which is this one, and then the distance from this axis. Okay, so the distance is equal to 2 meters. So we just need to substitute that one. So moment clockwise would be weight of the boy times the distance, which is 2 meters. Then we solve for the anti-clockwise. So again, clockwise going direction like that, and anti-clockwise is direction going this. Okay, so moment anti-clockwise, the weight of the girl, WA, times the distance. So weight of the girl is given to it's 400 Newton, and then the distance is 2.5 meters. So we just substitute everything, then you will have 400 Newton times 2.5. So with this equation, we can actually use this equation to solve for our principle of moment. Okay, then adding it to our principle of moment, because there's no other moment clockwise or moment anti-clockwise, there's only one for each. So we put the moment here, this one, the formula here, and formula here. Then after that, we put 2 meters on the denominator of this one to get our weight of the boy or the child B. Then we have this equation, and using your calculator, you can actually solve the weight of the boy, which is equal to 500 Newton. Okay, so that ends our topic for turning forces. So I hope you have learned something in our discussion, and enjoy the rest of your day.